So now that we've had a chance to talk a little bit about what monitors are and monitor objects are, let me give you a motivating example to illustrate why we need these things in the first place. And so this is going to be a fun little program. I'll show you the code for it and the link to learn more about it. It's called buggy queue. And as the name implies, it's designed intentionally to not do the right thing when multiple threads access it. So we're going to have a couple of methods, offer and poll. And as we'll see, they have a couple fatal flaws that make them very buggy. So the producers and consumers run concurrently, and they try to kind of put and pull things out of the queue. And as you might expect, chaos and insanity ensue. So here's where you can get the code for this. It's called buggy queue. And what it's trying to do is it's trying to pass messages from a producer thread to a consumer thread in an Android app. And as it turns out, bad stuff happens. So the intent of the buggy queue is to do something along the lines of the array blocking queue. If you recall array blocking queue, we talked about that when we discussed reentrant locks. We talked about that when we talked about condition objects. And the intent is to have this bounded queue that you can put things in and take things out of. Here's the basic diagram of how this works. So buggy queue is the class that we write, and it implements the Java bounded queue interface. And that's just because that's what array blocking queue does, but this is going to be a buggy version of things. So here's kind of what the test program looks like. We have the main thread of control, which runs in its own thread, of course, and it goes ahead and makes an instance of a buggy queue, and then we make a new consumer thread and a new producer thread. We start the consumer and producer threads. They're now often running concurrently. And the producer thread offers stuff to the queue that's basically a non-blocking put. And the consumer thread will poll, which is a non-blocking take. And they're going to run concurrently. And since the methods are not synchronized, chaos and insanity results because there's no locks. So let's take a look at the implementation and see just how bad it is. Here's buggy queue. You can see buggy queue implements bounded queue. You see it goes ahead and creates a linked list. This is just a good old Java linked list, which does not have any synchronization in it. By design, it's not intended to be synchronized. Here are the non-synchronized methods, offer and poll. And you can see what they do is they go ahead and add stuff and remove stuff from the queue. But you'll see there's no locks, there's no synchronized, there's no nothing. So as a result, it's just going to be a big mess. So that was the example, and I'll show you in a second what happens when you actually run the code. But this is sort of a what not to do kind of thing. You never want to write code that has no locks in it and then expect it to work properly when run with multiple threads, because bad things will happen.